This is a video on finding the degree of a Mclaurin polynomial needed to approximate a value. The question states, find the degree of the Mclaurin polynomial needed to approximate e with an error less than 0.001. So we're going to use the remainder theorem that says that the remainder, or the error, in using a Mclaurin polynomial is equal to the n plus first derivative of some number between our 0 and the number we're looking at. In this case, it's going to be 1. We'll see that in a second. Divided by n plus 1 factorial, x to the n plus 1. So we want to approximate e. So we can look at the function f of x equals e to the x. And if x equals 1, then we get e. So there's our function and our value of x. So now we notice that the derivative of f of x is e to the x. And if we keep taking derivatives, we always get e to the x. So in particular, the n plus first derivative of e to the x is e to the x. And if we plug in z, we get e to the z. So notice that e to the z is an increasing function between 0 and 1, which means that it reaches its maximum when z equals 1. So we can say that e to the z is less than or equal to e to the 1. And we're trying to approximate e, so we don't know exactly what e is, but we do know that it's less than 3. It's 2 point something. So now let's plug in. We know that the n plus first derivative evaluated at z is less than 3. We know that x is 1 is what we're looking at. So we can say that our remainder, or our error, is less than 3 divided by n plus 1 factorial times 1 to the n plus 1. And that's just 3 over n plus 1 factorial. So I want this remainder to be less than 0.001. So in order to do that, there isn't going to be algebra that I use. Instead, I'm going to just do trial and error. I'm going to try plugging in some values of n and see what I get. If I plugged in n equals 5, then n plus 1 is 6, and 3 over 6 factorial is 0.0042. Well, that error is bigger than 0.001, so that didn't work. So now let's try 7 factorial in the denominator. And 3 over 7 factorial is 0.0006, and that is less than 0.001. So there we have it. We want to make sure that n plus 1 is equal to 7. And of course, just subtract 1, and we can conclude that we should use a 6th-degree Mclaurin polynomial to approximate e with an error less than 0.001. And I'm done with the problem.